Hi everyone, welcome to Tech Study YouTube channel. In this video, we will learn about what is an algorithm and its specifications. We will start with our first topic of Module 1. What is an algorithm? An algorithm is a finite set of instructions that, if followed, accomplishes a particular task. In addition to the definition, all algorithms must satisfy the following criteria or properties. That is, an algorithm must take 0 or more inputs externally. It should produce at least one output. Each instruction should be clear and unambiguous, which we will call it as definiteness. Next, the instructions in the algorithm should be able to trace out for all cases, and it should terminate after a finite number of steps. Lastly, algorithm instruction should be effective so that anyone can solve it by pencil and paper. Question pattern for this topic in exam will be given here, which can be expected for 4 to 8 marks, which is very important. Next, we see algorithm specification. We can represent algorithm in many ways, which can use natural languages like English or graphic representation called flowchart. But both can work good for small and simple algorithms. So most used method is pseudocode convention. Pseudocode convention is a combination of natural English and coding representation. We'll just go through some of the notations used in this convention. First is comments, which begins with slashes and continue until the end of the line. The body of the procedure forms a block which are indicated with matching braces. Statements are delimited by semicolon. An identifier or variable names begins with the letter. Compound data types such as structures and unions can be formed with keyword record. Here is an example. Assignment of values to variables is done using the assignment statement. There are two Boolean values, true and false. In order to produce these values, the relational and logical operators are produced. Elements of multidimensional arrays are accessed using square braces. The while loop, for loop take the following form, repeat, which is equivalent to do while loop in C programming. A conditional statement if else takes the following forms. Input and output are done using the instructions read and write. And finally, there is only one type of procedure algorithm. Before next topic, let's discuss about algorithm types. Algorithms of two types, recursive algorithm and non-recursive algorithms. We will see what is recursive algorithms first. A recursive function is a function that is defined in terms of itself. Similarly, an algorithm is said to be recursive if the same algorithm is invoked in the body. Recursive algorithm is of two types, direct recursive and indirect recursive. If an algorithm that calls itself is called direct recursive, then algorithm A is said to be indirect recursive if it calls another algorithm which in turn calls A. The following two examples shows how to develop a recursive algorithm. One is Tower of Anany and another one is permutations of first list of characters. Question pattern for this topic in exam will be given here, which can be expected for 6 marks, which is very important. Analysis framework. In this section, we outline general framework for analyzing the efficiency of an algorithm. There are two kinds of efficiencies. Time efficiency, also called as time complexity. It indicates how fast an algorithm runs. Space efficiency, also called as space complexity, which refers to the amount of memory units required by an algorithm in addition to the space needed for its input and output. Primarily, we concentrate on time efficiency. Let us start with unit of measuring running time. Running time of an algorithm is measured using some function of parameter n. This will be clear with following examples. Means in sorting and searching algorithms, input size of an array is n integer. In polynomial problems, it will be n degree. Likewise, in spell checking algorithms, input size will be the size of the number of characters. So one or other way, in all algorithms, some function n is a measuring unit. Next, measuring an input size. We saw in previous topic n is measuring unit, then what size of n we consider as an input size of an algorithm. So this depends on the number of important operations in an algorithm. This important operation is called as basic operation of an algorithm. So measuring input size is done by identifying the most important operation of an algorithm and then counting the number of times the basic operation is executed. For example, in sorting algorithm, basic operation is the key comparison. Finally, this is represented with the equation T of n is approximately equal to COP into C of n, which is called as order of growth of an algorithm, where COP is the execution time of an algorithm's basic operation on a particular computer. C of n be the number of times this operation needs to be executed for this algorithm. Next is order of growth. What is the importance of order of growth? It's important because for large values of n, it is the function's order of growth that counts. Just look at the table which contains values of few functions particularly important for analysis of an algorithm. The function growing slowest among these is the logarithmic function. On the other end of the spectrum are the exponential functions 2 to the power n and the factorial function n factorial. Next, we see worst case, best case and average case efficiencies. The running time of an algorithm can be different for same input size n. So, worst case efficiency is algorithm's efficiency for the worst case of input size n, which is an input of size n for which algorithm runs longest among the possible inputs of the size. Likewise, best case efficiency is for which algorithm runs the fastest among all the possible inputs of the size. So, average case efficiency is neither the worst case nor the best case. It's an algorithm's behavior on a typical or random input. Let us see an example. Sequential search algorithm. In this algorithm, input size is n. Basic operation is the key comparison, that is, a of I is not equal to k. If we see how many times basic operation is executed, the worst case efficiency will be C of worst is equals to n, which means n times the key comparison is made. Likewise, the best case efficiency will be C best of n is equals to 1, means first element itself is the key element. So only one time comparison is done. Then the average case efficiency will be given below, which is P of n plus 1 by 2 plus n of 1 minus p. Finally, if we recall all the points from the analysis framework, both time and space efficiencies are measured as functions of the algorithm's input size. Time efficiency is measured by counting the number of times the algorithm's basic operation is executed. Space efficiency is measured by counting the number of extra memory units consumed by the algorithm. The efficiencies of some algorithms may differ significantly for inputs of same size. For such algorithms, we need to distinguish between the worst case and average case and best case efficiencies. The framework's primarily interest lies in the order of growth of algorithms running time as its input size goes to infinity. Question pattern for this topic in exam will be given here, which can be expected for 6 marks, which is very important. In next video, we'll see about performance analysis and asymptotic notation. Thank you for watching the video. Any questions, please comment. See you all on our social media accounts. Thank you and support us by subscribing. Shalom.